Okay, I'm back, and so now I've got large sample pictures for each of these different kinds of rock types. So you got rhyolite, andesite, and basalt, and then underneath it you got the granite, the diorite, and the gabbro. So if you go back to this slide here, we're talking about that very bottom set of 6 rocks. So let's start off with rhyolite and granite. They both go together. They're both made of the same felsic minerals. So they're going to have a lot of quartz, a lot of feldspar in them. They're light colored. So notice that they tend to be very light in color because they have light colored minerals in them. Notice that the granite is going to have crystals that you can see, and rhyolite does not. So that tells you that rhyolite forms near the surface of the earth as lava flows. On the other hand, granite cools off at great depths inside the earth and becomes the rock granite. Now let's skip andesite and diorite for the moment, and let's go over to basalt. So basalt is the material that comes out of mid-ocean ridges and forms the floor of the ocean. And then if you recall, I said that underneath the basalt was the gabbro. So that ocean crust was composed of gabbro on the top, basalt on the top, and then gabbro underneath. And that's the reason why, is because the basalt cooled off quickly because it was near the surface, and the gabbro cooled off very slowly. And notice that you can see crystals in the gabbro. So they are made of mafic minerals. The rhyolite and granite were the felsic minerals. The basalt and the gabbro are the mafic. So they're going to have more olivine, pyroxene, and amphibole in them. Now what about the andesite and the diorite? So where do they come from? So they're going to come whenever you mix rhyolite and basalt, or you mix granite and gabbro. And so where would you have mixing occurring? So that's going to be at a subduction zone. So where you've got a lithospheric plate, an ocean plate that's going underneath a continental. So the oceanic plate is going to be mafic, and then the continental plate is going to be felsic. So when this melts and the materials come up through the volcanic mountains, then that's where you're going to get your andesite and your diorite from. So that leaves us with the one there on the end, the periodotite. And so where does that come from? So that is the mantle. That is ultimately the source for all of those other rocks. So as that material comes to the surface, it eventually changes into gabbro and then basalt, and then given enough time and you keep having subduction zones, the basalt and the gabbro can eventually become granite continents, and then where the granite and the ocean plates come together, you get this intermediate stuff, the andesite and the diorite. So later we'll talk about the formation of continents and where do they come from and how do continents evolve. Okay, let's go ahead and do this one. So here are some kind of special examples of igneous rocks, and actually all 3 of these are the pyroclastic rocks. So rocks that tend to form either at the surface of the earth or as they're flying through the air. So pumice has an unusual property that pumice has so many gas holes in it that it reduces its density to the point that it would float in water. So it's like the only rock that will do it. You can take pumice and put it into a glass of water and it would float because it's not so dense, because it has a lot of gas holes in it. Sometimes this pumice has so much gas in it that's trying to get out that the pumice basically explodes, and then you get little shards of glass, and then that's going to turn out to be volcanic ash. You can also see, though, that sometimes the pumice will rain down and it will be glued together, and you can see that there's layers in it, in some pumice as well. Pumice has a felsic composition, as opposed to scoria, which is going to be mafic. So it has a more mafic composition, but you still see it's got the air holes, gas holes. So as the gas was escaping the lava when it's at the surface of the earth, that's what's making all those holes in that scoria. Okay, now the obsidian, okay, it froze before it had a chance to make any crystals whatsoever. So another name for obsidian is going to be volcanic glass. And you can see that it's very sharp, and so Indians like to carve obsidian in order to make their arrowheads with. The one that's next to it is called tuff, and so that is different kinds of volcanic materials that have been welded together to make a very dense rock. And so we're going to call that tuff. All right, let's take a break, and when we come back, we're going to talk a little bit more about plate tectonics, and then how that is involved in the formation of igneous rocks.